Hello guys, my name is Divesh Jadwani and I welcome you to my YouTube channel. So guys, super happy to tell you that now I'm dropping the third part of this LLM security series, which is LLM Gateways. Now Gateways is a very important software level integration which you have to do in your LLM applications. Why is that? We want to make fault tolerant systems. We want to, make very highly secure and robust systems. We want to make a system in such a way that it will never face any kind of downtime, all right, to maintain the reputation of the organization. So for all of these different kind of reasons, we go ahead and make LLM gateways or integrate LLM gateways in our LLM applications. So let us go ahead and talk about it, that what are LLM gateways, what is the need of LLM gateways, and what are the different things to understand when it comes to LLM gateways. Let us understand what is LLM gateways. This is also a very trending topic, a very important topic as in terms of large language model implementations and applications. Now, what is LLM gateways? It is also a security level component of your LLM applications. Now, if someone will ask, is LLM gateways or is gateways, all right, is gateways a new concept? No. Gateways is a very old concept which has been introduced in software engineering from very long time. I've always said that AI softwares are softwares in the end. AI engineers are software engineers in the end. All right. So all the software development lifecycle, which we say SDLC concepts, also apply on AI SDLC, right? AI software development lifecycle, as simple as that. So yes, gateways was there earlier as well, but with the rise of LLMs, gateways apply to the large language models as well. So we'll see how it works and how it secures our large language model. Majorly, very majorly, it also the major portion is it acts as a security layer, but it also acts as a major backup layer. Okay, backup layer. Why do we need gateways? Okay, let us talk about the need of gateways, or if I specifically say LLM gateways, right? So the need of LLM gateways is, first, we want to make fault tolerant systems. We will take a simple scenario to understand fault tolerant systems. For example, see, what used to happen is, this is a user and a user is using, or user is interacting with a chatbot or some AI service, AI as a service platform. All right, user is chatting with some AI service on some random website. And what happened? Okay, internally they are using something OpenAI in the backend, or maybe Meta in the backend. Any AI models they are using in the backend to make their particular solutions. Now, if it is only 10 users, it is fine. But if 100 or million users are using this particular application what point of time, high user traffic, then this is a problem. Why? What if they are using this and the API limits are over? Okay, if you don't know what is API limits, so every time you use a model, let us say OpenAI or Meta, right? We have used the free versions of the chat. All right. If we exceed 10 chats, or if we exceed 15 to 20 chats, we get some message like your API credits are over for today. Okay. Come back tomorrow or subscribe to us. Okay. So the API limits, what if the API limits are over? Right? Or what if let us say we have a subscription plan and our entire AI system, right? For example, we are a edtech platform, and edtech platform has a marketing agent. Now what this marketing agent is going to do, this marketing agent is going to talk to the customers, whoever is coming to our website, and tell us that what kind of courses we offer. For example, agentic AI, data science, we offer these kind of courses. And what if all right, internally, this, the agent which we are using, let us say the service of agent to run this particular chatbot is OpenAI, and our entire system is running on OpenAI. What if OpenAI is under development? Okay, It is a very, usual scenario. Server down. Okay, server downtime. If OpenAI is going under development and there is server downtime, our application will also be down for that particular point of time, or maybe this particular service, the chatbot service, will be down. How bad it would look if a customer is chatting with our chatbot, and our chatbot is saying that backend error, okay, API limit error, or I am not available at the moment, I am under development. That will not be good. Okay, that will be lose of traffic. There we will lose some customers over there, some revenue will be lost. All right. So fault, this is a fault, right? Now the fault can happen if the service is down, or if our subscription is out, right? When we were, kids, we used to have some balance. We used to have talk time balance in our phones. And people who used to chit chat a lot, in 15 days their balance used to get over, even though it was charged for 30 days, because we had some limit, right? So now balance is over. Now we cannot call anyone, only incoming accepted, no outgoing. People used to say that I don't have balance. All right. Now it is cheaper, but earlier it wasn't. So this is a problem, this is a fault. To tolerate this, okay, to survive through this, gateway is important, right? Now second one is, security. To keep our system secure, okay. Now what we learned is guardrails, right? We have learned about guardrails. Now guardrails is a part of gateways. All right, guardrails is a part of gateways. So we want to make fault tolerant, we want to make secure systems. All right. And third, we also want to make robust systems. Now what does robust system means? Robust systems which are very fast and low latency. Now how do we achieve that? See, internally we don't have to use only one model. Earlier, the scenario which we know is user will talk to only one model. Let us say OpenAI, Grok, or whatever model it is in the backend. But if service is down, it is a problem. So how do we solve this? We have a user. Now it will first interact with our gateway. So this will be gateway coming into the picture. A LLM gateway. Now gateway is as simple as having a gate in front of your door. Take it as simple as that. Okay. Directly you cannot hit the door. First enter through the gate, make your entry, let us see you in the camera, or let us verify you, and then enter in the house. Now what will happen is, here internally, instead of using one model, we can use three models. This is OpenAI, this is Grok, and this is Claude or Gemini. Okay. Now we will use three models. For example, if one will not work, other will work. If other will not work, the third will work. All right. So our system will never fail. That is how it will become fault tolerant. Secondly, see, OpenAI models are considered very smart for content generation. Okay. Grok models are good for fast tasks, small level tasks, writing an email, all those kind of tasks, right? And Gemini is good for generating images. Okay. All of these different models have some, some speciality, right? So depending upon the user query, we want to, if a user is just telling me, generate me a YouTube thumbnail. Okay. And internally, we know that whenever images are coming into the picture, Gemini model should be called because it is doing an amazing job. So this request should be automatically sent to the Gemini. If the user is something like, write me an email to, get me a vacation holiday. So in this particular scenario, request should directly be sent to the Grok. Okay. This particular concept which I'm talking about is called model routing. We will see this in action. Each concept we will see this in action. Okay. If the question is regarding generating some content, okay, writing me a prompt, good prompt, high quality prompt, then request should be sent to OpenAI. So request based routing. All right. And also there is one more thing, load balancing. Now what does load balancing means? Let me cover this concept as well. Load balancing. Okay. Load balancing means if you have We were balancing load only right now. Okay, if you have 10 users, okay, or let us again do that. This each user is per 100 users. Okay, this is 100, this one is 100, this is 100, and this one is 100. Okay, and here in between we have a load balancer. Okay, load balancer is going to handle the load of user traffic. This is user traffic, 400 users, right? Now internally we have different models. OpenAI model, so chat GPT. Gemini model, so G.ai, and third we have Claude. Okay, all good models. Okay, all are good models, capable models. Okay, what we will do is, for each 100 users we will send them, these 100 users will be sent to GPT, these 100 students or these 100 users will be sent to Gemini, these 100 will be sent to Claude, and 50 of them will be sent here, 50 of them will be sent here. Okay, balancing the load of the users with the respective models. Again, we are routing the users to different models, right? This is what is, making the system faster, low latency, fast response. Because if 400 requests, okay, 400 users are all hitting this particular GPT, it will not tolerate it. It will tolerate it, but the response will go slower and slower. Okay, so let me show you a good demonstration also so that you understand. This is the app which we are going to study, and this will also be provided to you. Okay, now let me go over here. I will show you something. Okay, I'm opening some platform, something called as Portkey. Okay, Portkey is a production grade application or a production grade framework when we want to use gateways. Okay, so we can check their GitHub first. We can see 12.3k stars. 2 months ago, active development is going on. Okay, so now we can just get started for free. Or let us look at this demo first. See what they are showing us. Check this demo. All right. It is helping us to check how much was the cost, how many unique users, how much cache we have. We'll talk about it. Okay. Right. How many, which was the query sent at which particular point of time. All of this tracking, we can do it. What are the solutions it offers? Role-based access control, cost optimization. I will talk about cost optimization. Centralized AI model access. Okay. Organization-wide audit logs. Whatnot. Okay. Product. It helps, it gives us observability in it. So this what we are seeing is observability, which you have understood, right? This is observability. Gateway is inbuilt. Guardrails is inbuilt. Prompt engineering. There is something called as prompt versioning. I will talk about it. Okay. AI agents. Security and compliance, which means all different countries have different security compliances, OWASP and whatnot. Okay, Cisco's. So different, depending upon different countries, we can have different compliances. MCP gateways, I will talk about that as well. Model catalog. Okay, so let me quickly sign up and show you something. Okay, I am just going to sign up with Google and check this out. We can see a dashboard. Okay, we can see how much cost I have spent till now. I have spent $0.05 till now on my models. How much latency? I, on an average level, my models are giving reply in 208.5 milliseconds. How many requests I have received till now? 100 requests are received, which means 100 times my model has been triggered. How many unique users I have? 4 unique users have come to my website. Okay, 4 unique users have communicated with my chatbot. Now, having this kind of analytics is just so amazing. Okay, we are still talking about the observability part. See, 4 different users we can trace. Which users has used it the most, which means how many requests have come by which users. Okay, which are the AI models used internally? OpenAI is used, Llama is used, right? Okay, tokens used. How many tokens we have used, which means how many words. So 80,000 words are utilized till now, right? We can check this on a user level. Okay, request per user. We can check something called as caching. I will talk about it, right? feedback layer, and summary of how many. So we have used one particular service, Grok, which has received 100 requests, 4.97. So amazing analytics, right? Now you have to also know that only Portkey is giving this kind of luxury. Not all frameworks give you this kind of luxury. Okay, so with that, I hope now you know what is gateways. Okay, gateways helps us to make fault tolerant, secure, and robust systems. Okay, and I can also add traceable systems, but I hope you get the point, right? And cost efficient systems as well, not only robust. The fourth point will be, let me also add the fourth point. The fourth point will be cost efficient systems. All right, audience, wasn't that so simple understanding LLM gateways? Now that you have built a good base around LLM gateways, let us talk about the different frameworks or the different technologies which you can integrate in your LLM applications in the form of gateways. So now we will go ahead and understand what are the different frameworks for LLM gateways, for integrating LLM gateways in our software, right? Just how we learned for guardrails, there was Nemo guardrails, AI guardrails, AWS Bedrock guardrails, different guardrails. Similarly, we have different frameworks of gateways as well. So the first and my favorite is Portkey, which is what we just saw. Portkey, let me write it properly. This will be Portkey. All right. Second one is LiteLLM. Okay. Third one is Bifrost. All right. Fourth one is OpenRouter. Okay. There is much more of them. There is also something called as Cloudflare. Okay, I will write it down. Cloudflare. Okay. Kong. There are many. Okay, there are many. I will talk about the famous guys. Okay. Now let us talk about the best framework, which we are going to see upcoming videos. Portkey. Okay. Portkey is the most feature complete framework. Feature complete framework. Okay. All these concepts which I was talking about, no framework gives you guardrails, gateways, observability, caching, load balancing, all of that in one place. Portkey is giving you, and that is why I'm referring it to as feature complete. Okay, if I go to Portkey website, this is Portkey website. Okay, let me go to Portkey literally. See, this is the Portkey documentation. And as always, you are supposed to go through all the documentations of all the frameworks which I'm showing you. LLM integrations, which means who are the partners of Portkey. So they have supported, the supported AI providers are from all the organizations, OpenAI, Anthropic, AWS, Vertex, all of them, DeepSeek, any framework, you name the framework and they have it. 1600 plus models supported. Portkey. Okay, 1600 plus AI models supported. Okay, gateways, APIs, Portkey SDKs, and lot of them. We will come little bit behind. Okay, and we will talk about this as well. Let me go much more. AI apps, with which AI apps it can work. All of these AI apps, OpenClock, Cursor, N8N. Okay, this will be integrated with any application. You name the application and you integrate with. Okay, then cloud platforms, which cloud platforms are supported. So of course all the cloud platforms will be supported, right? And MCP servers, we will talk about MCPs, which AI agents can be connected. So OpenAI, Pydantic AI, Crew AI, Llama Index. See, this particular framework is giving you integration with any framework. Okay, as diverse you can go, this framework will also go as diverse. Guardrails, which guardrails frameworks? See, AWS Bedrock, Aporia, okay, Activity, Azure, Javelin, Lasso. These all are different guardrails frameworks. Okay, we might have not covered it. Mistral. See, These all provide us guardrails. Okay, you can check that out anytime. F5 guardrails, Vault AI, right? Zscaler, you can check them. Okay, all the good organizations, industry grade organizations, right? So lot of them you can check it. Okay, introducing agent gateway, governance, observability, controller agent. So we will also talk about AI governance, okay, in the upcoming times. Now, this was Portkey, best of all. Second one, if you are trying to go for a free solution, open source solution, LLM is the light LLM is the go-to option. Okay, and in my experience, I have used 1, 2, and 3. I have not used this, but it is not hard to use it once you know the concepts. LiteLLM is the biggest open source framework of gateways. Okay, let me go to LiteLLM. We'll go to LiteLLM. Okay, I will search here. This is LiteLLM. Okay, and I will also go to LiteLLM docs right from here, and I can also go to GitHub from here. First, let us check the GitHub stars. 52.6k GitHub stars, very wide community. 7 hours ago the last change was made, active development. Okay, get started. LiteLLM, see what I'm showing you. Isn't this the diagram which I was showing you? Okay, a developer will use it. LiteLLM can integrate any LLM, any A2A. A2A means agent to agent. For example, you have made an AI agent in Crew AI, and you have made another AI agent in LangGraph. How will both of these communicate on a network layer? This is called A2A, agent to agent protocols. Okay, MCP protocols, right? So we are yet to cover all of these terminologies. If I show you the website, this is the website. See, this is what the diagram I was showing you, right? It can be routed to any one of them. If I open model access, okay, which models can be accessed? This also helps us to integrate with 1500 plus models. Okay, 1500 plus models. And this is amazing, right? All the features are over here. Uptime, 100% uptime. It will never go down. Okay, and this is open source, free, right? Budget and rate limits, OpenAI compatible. So OpenAI compatible is the standard, which means OpenAI guys brought the SDK first, and then it became the standard way of integrating. Okay, LLM fallbacks. See, if OpenAI is not working, switch to Azure, right? So all of this, LiteLLM, amazing framework. Okay, you should go through the documentation once. This is the documentation. You can see Python SDK. So you don't have to understand how to program. You have to understand what all things are there in this. Okay. Now, this was LiteLLM. Thirdly, let us talk about OpenRouter. OpenRouter is also a free resource. The name suggests OpenRouter, but it has less integrations. So I can show you OpenRouter. And with the help of OpenRouter, you can use Cloud Code free in your systems if you don't know that. This is OpenRouter. It also has integrations with, many models, 400 plus models. Portkey has 1600 plus. This has 1500 plus, 70 plus providers, right? So I'm showing you how do you explore, how do you explore these particular frameworks. Okay, how do you keep up? How do you research about these particular frameworks? You should check their documentation, right? You can go to their GitHub. So if I just check out the GitHub, they should have it somewhere. Okay, I can just check their GitHub somewhere, documentation, and somewhere they should have their GitHub, or we can search their GitHub. For example, OpenRouter GitHub. OpenRouter GitHub. Let us check the stars. Okay, I can open that. So yeah, you can check that. I think I opened the main page directly, but internally you can open any particular repository. And Python SDK, if you open the Python part of it, 137 stars, and 33. So 13 hours ago, active development. Yeah. So yes, this is one. And let us understand the last one, Bifrost. Bifrost is also amazing. Okay. Open source high performance gateway. This is the word we have to understand. This is the fastest gateway. Okay. if I say this is the fastest of any gateways, not even Portkey is, as fast as this. This is very, very fast, extremely fast. The routing which it is doing internally, it is very fast. But only drawback of this is it has less partners, less integrations, less model providers. Okay, not all the models and all the features are there in Bifrost, but Bifrost is famous because the performance which it gives is better than any other framework. Okay, so if we want to integrate a solution which is most feature complete, all the features we want to integrate, go for Portkey, and it is the production grade. For any production application, you use it. If you're developing POC, proof of concepts, MVP projects, go for LiteLLM. Okay, or Bifrost. Sorry, go for LiteLLM. But if you are developing some solution which needs very high performance, fast response, okay, very ultra low latency, Bifrost is go to. Okay, and if you want to explore gateways and try out a solution, OpenRouter is go to. Now Cloudflare you might have seen many times on the authentication part. When you authorize yourself onto some application, you might have seen Cloudflare, right? So when you are already using Cloudflare in your systems and you want to integrate Cloudflare only as your gateways, which means similar kind of providers, you trust this provider, you use it, you can go for Cloudflare. Okay, so those were all the frameworks which you can utilize, and there are literally many more frameworks which you can utilize for your LLM gateway integrations. Now that you know about this, let us go ahead and talk about a very good and a very important concept which is called as virtual keys. Key exactly. Now see, if you want to use any LLM, you specifically go to the provider. Any provider it can be, OpenAI, Gemini, Grok, right? When you go to these providers, they give you something called as API key. And using this API key, you can integrate this particular LLM in your particular application. This is all we know. But now we are talking about, increasing the number of models. Why? Because what if one particular model is failing? Okay, it is down, it is not able to answer, or it is, retrying. Okay, the request is not being sent to the model. So in that case, a second backup model should be ready. If second one is failing, third should be ready. If third is failing, fourth should be ready. Now, when we are developing, okay, all these API keys we have to take care of. There is something called as .env file. It is called as an environment file. So in your entire project environment, this particular is ingested. This particular file is ingested, and this file contains all the API keys. Now the task is to manage these API keys is a problem. Okay, because keys will increase so much, it will be a problem, right? When you deploy this on the cloud, okay, in your CI/CD pipelines, continuous integration, continuous deployment pipelines, when you do this deployment, that time also you have to ingest this particular key in the environment. Okay, what if it's with slight chance you might, do some error in your API key, right? Or what if you forget to mention one API key? Because this is just the LLM API keys. For each service which we use, for each service we need an API key, right? So handling over 10 is a small number, okay? Handling over 50 API keys is a problem. Okay, so why not give someone else to, handle our API keys? So what Gateways tells us, what Portkey tells us, hey, give me your API key, I will give you a token. Okay, how it works is, so we have been to temples, right? If you go to temples, okay, you have a shoe rack. Okay, shoe rack. How it works is, there is a man standing over here. You will go here, you will give your shoes to him, and what he will give you in return, he will give you a token. Okay, which means this token number 43 represents your shoes. When you give me back this token number 43, I will give you your shoes back once you are back from the temple. Okay, similarly, what we do is we give our API key. We give our API key, no matter one API key or 100 API keys. How many models we have, all the API keys, we can give this to our gateway. Okay. Gateway will tell, don't worry, I am secured, I will keep it with me. Okay. So my company is, trusted and confident. We will secure your API keys. Don't worry at all. Okay. So Gateway will keep our API keys. Okay. And Gateway will give us something called as virtual keys. Now this virtual keys is as good as the token I told you about. These virtual keys represent this API key. Okay, now API keys we have seen, they are something like this: AI, A, B, C, D, some big alphanumeric digit. We give this to Gateway, and Gateway tells us what name would you like to give to this. So we can also give it a name, right? So I can say that I would like to give this name as, my RAG project key. Okay. Similarly, for some other project or for the same project, I can give another API key and call it RAG2. Okay. Similarly, if I have a third project, I can call it Agentic 1. Okay, Agentic 2. So one particular gateway I can integrate in all the projects of my organization. Okay. So now we will maintain 1,000 API keys for different projects, right? Everything will be taken care by gateways. Okay, but if gateway is down, if gateway is hacked, okay, it will all be down. So this is the downside of it. If gateway only is not working, okay, if there is a server downtime on gateway, then we will not have you know no purpose of all this. But what we read in the LiteLLM framework, 100% uptime, okay, it will always be up no matter what. So similarly they all claim, right, that will not go down, and that is why we trust them, right? So we will get something called as virtual keys. Now virtual keys have a technical word, and this word is called slug. Nothing else. You just call your friend. You have a friend, okay, you will call him a homie. He's my homie, right? Similarly, you have something called as virtual key. You are calling it slug. You are giving it a name, technical name, slug. Okay, so let us go ahead and now make a account on Portkey. Okay, I'm just going to take a new ID and I will make a account on Portkey in front of you. Okay, so I'm going here. Okay, I think I've made an account on this earlier. I will just take some random different account of mine and I will make Portkey over here. Portkey. I'm showing you how do you log in onto Portkey. So I will go to Portkey. I will sign up. Okay. I can sign up with Google. All right. All right. So I guess for all the applications I have used Portkey. No worries. Okay. How it works is you will have, the moment you log in into Portkey, you will have getting started page. Okay. And getting started page, the moment you go in Portkey, you will get Portkey API key. Okay. Portkey API key. This is my API key. All right. Now, see, to use Portkey in your system, now instead of you handling 100 API keys, Portkey will handle your 100 API keys. But how will you tell your system that, hey, I'm using Portkey? So you will need Portkey API key for that, right? So that is why Portkey will give you API key. So this application which I have right now, which is this application, LLM Gateways, the first thing it is asking us for Portkey Gateway API key. All right. So we will enter Portkey Gateway API key. Now, secondly, it is asking for Grok model, Grok API key. So we know we can go to grok.com, okay, and we can get API key from here, okay, and we can enter this. Now you will be thinking that why it is like this. You are saying that Portkey will handle all the API keys, but why are we entering it now? Only for the first experiment, to show baseline, to demonstrate an experiment where there is no gateway, how life is without gateway. And then we will see 10 different scenarios that how life is with gateway. Okay, so to demonstrate this life without gateway, we will have to use this Grok API key. Okay, and then see what is asking. It is asking us virtual key slugs. What are your slugs? So I will go ahead and show you how to make it. Let me go here. Okay, here you can make a new slug. You will have an option of making a new one. So I can just go here, new integration. You will by default have a new integration. So I can go to new integration and I can give which provider I'm using. So I will scroll down and I can see so many providers are here. I will choose my provider, which is Grok. I will click Grok. Okay. I will enter a name. Okay. The name I will enter is, ABC1. Okay. ABC1. Now this is the name of the key which I'm telling that, hey, ABC1. And you can see automatically this has also become the slug name, which means this will be the name which will be used for a Grok model. Okay, understand this. What is virtual key? If I want to use Grok API key, I will get the API. I will give this API to my Portkey. Instead of this API key, Portkey will give me a token, just how that shoe rack person gave me. There will be a name of this token, and this name is called as slug. And I've written rag over here. Instead of this, I will write ABC1, which I just showed you, ABC1. See, the name will be ABC1 instead of what? Instead of a API key. So I will go here on Grok. I will generate a new API key. So I will call it ABC1. There's no need to keep same names. I'm just keeping it standardized. Okay. Let me copy it. I will copy this and I will paste this. Okay. I've pasted this API key. This is my slug name. And when I create it, okay, my ABC slug will be created. Okay, now if I show you some code, don't worry about this code. If I show you some code, see how are we accessing a model over here. First we tell that, hey, this is my API key, port key. To use port key, this is my API key. And secondly, to use my any model that I want to use any model, I will first tell that ABC1, from ABC1, I'm using this model. Okay, so this becomes my slug, right? Similarly, I can make a new integration and I can again make a new, slug ABC2. We have to make backup slugs, right? If one fails, another. If second fails, third. So I'm making a backup one again, new integration. I will give it a name. It already has picked it up from that. I will just paste my API key. Now, this time you will make new API key from another Google ID and paste it. And I will create it. And I've created two slugs with the name ABC and ABC1. So what all things I have to do? I have to take my API key, Portkey API key. This will be my Portkey API key. And I will paste it over here. See, I will do it. This is my Portkey API key. I have pasted my Portkey API key. Press enter. This is my Grok for only baseline demo. And what are the name of my virtual slugs? I can call ABC1, press enter, and ABC2, press enter. Okay. And this is how this particular application will be set up for us to, experiment and learn each of the concepts. Let us now understand each of the experiments one by one. We have 10 experiments. We will break them down properly with all the diagrams and everything. So see, diagram is also provided over here on the application. Now this is life without gateway. Your application is directly interacting with a model. Okay. Now what I will do is I will fail this model. First, I will show you how it is working. So I can just simply ask what is life. Okay. Or I have given you different questions as well. You can just choose and call the question. Run baseline call. It is telling me this is the number of time it took. This is the tokens. This is the completion tokens. And this is the response given. Okay. Now what happened is we cannot see any trace on Portkey. If I go over here and if I go to analytics, so on analytics you check the spikes. I can see no spikes over here. Nothing has come into the picture. Okay, we cannot trace our application. Okay, we do not have a backup. So see, if I mess up this API key, I messed up this API key. I removed the last one. Now if I run this baseline call, it will not work. Okay, it will say that, hey, service is down. Okay, and once the service is up, then if I run it, then it will work, right? So I hope you understand. Life without gateway is good, but little bit risky. Okay, so now let us see how is life with gateway. The first experiment. With gateways having into the picture, the first part is we can start to trace our LLM calls. Okay, every trace we can observe. So your application, now it will not directly contact your LLM. There will be a gateway in between. We will send the request to gateway. Gateway will think, should I send this request to the LLM or can I do it without it? Okay. Forwarded request. If the request should be sent to the large language model, it will be sent. The response will be sent back. The response will be sent back like this. And this all will be logged on Portkey dashboard. Let us see how. Okay. So now what happens if, why do we dream? Simple explanation. I'm just taking a question. From here, I can pick a model. I will specifically pick a model. I will pick up OpenAI 20 billion model. Okay, my primary main model and my backup model is Llama model. Okay, if OpenAI fails. Now see, run through gateway. Let me run through gateway. Now if I run through this gateway, see what is going to happen. I run this question and see you will see a spike over here. Okay. Okay, we can refresh. A spike is over here. We can observe the call of our LLM. Okay. A request was sent. This is my email ID. This is the model used, OpenAI 20 billion model. Okay. Tokens used are 300. Okay. We can confirm it from here. 332. All right. So 300 tokens are used. Right. 32 will be the prompt tokens and 300 will be the response tokens. Now let us go in depth of analyzing this one request so that we can trace any request. I can go to logs. I can open these logs. Okay. And when I open these logs, I can, trace each request. So see, on July 4th, OpenAI model, chat completion. This is the user. This is the tokens it utilized. This was the cost, 0.01 cost. Okay. And if I open this, I can see the entire trace details. See, what was the question? What was the response? Okay. How much was the request timing? How much was the latency? Everything will be traced, right? So this is how to trace a LLM call, and this is how life looks like with gateways. Okay. We at least start to trace our application, right? Now let us go one step ahead on the next experiment and understand this much more further. Here, your application request will be sent. Now, earlier we were sending only the request. See, we are sending only the request. This time, we will not only send the request, but we will also send information with it, which means which particular user, which particular environment, okay, and in which particular zone we are using it. I will talk about this metadata. So metadata is extra information about your data. Okay, we always need to store metadata for good LLM responses. Now, if I go to Portkey Gateway, okay, so request is sent to Portkey Gateway. It will be forwarded to our LLM, and from the dashboard, it will be analyzed. Now, what we can do, we can filter and analyze these analytics. How can we filter? I will show you the demonstration first. So let us give a name, Rahul, right? Automatically a session ID will be created. Now, what is a session ID? See people, if I open ChatGPT, okay, if I open this ChatGPT, right now, currently we can only see chatgpt.com. There is nothing. But the moment I ask a question, what is agentic AI? See what's going to happen over here. Here, okay, see what's going to happen. We have a session ID, which means for this particular session, remember everything that user is talking about. So that is how it maintains a memory as well. For this particular session, if I just give, what was my last question? So it will only search here. It will not search anywhere else. So a specific unique session ID is created. All right. So this is one thing. Let me go here. So that is why a session ID is needed. Which feature are we using? So let us say we are using code assistant feature. In which development environment we are staging, production development environment. So this is just extra information that when are we exactly using this large language model. We can pass all this. We can pass all this. Okay. Now I can change the model as well. I can change my model. I can change this model to, OpenAI 120 billion model. Okay. And now I can ask a question. What is the mind-blowing fact about universe? I can just ask it. This time the question will be sent by Rahul. Okay, and this is how we trace users, different million of users on our website. Send a request. Let us quickly go. I guess we will see a new log over here. Let me refresh. See. New log. User is Rahul. OpenAI 120 billion model is used. 300 tokens are used. Status is this. Okay. Let us go here. We can see another spike over here. Okay. We can see spikes similar. Okay. If I refresh, we have Rahul in the picture. Rahul has sent one more question, and now the question was sent with 120 billion model OpenAI. We can also trace each user on a user level. See, 2 unique users we have, Rahul and my ID. See, and we can trace all of them. Let us see this quickly once more. Now here I will add Priya. Okay. Priya is working in development environment. She is working on customer support agent, and Priya is asking about explain butterfly effect. So this is the response, by the way. I was not showing you the response. You can see it yourself. Okay, we are interested in the feature. If I send this request, a new request will be incoming by Priya. Okay, Priya has used OpenAI model. Let me refresh. So we have 2 requests from this OpenAI model. So total 3 requests, 3 unique users, 1K tokens are used, cost is increasing, and logs can be logged. Priya. So this is how we do user level tracking. So see, filter, we can filter on basis of users. Okay. Or we can also filter on basis of, any filter we can apply. See, tokens filter, we can see who has utilized more than 300 tokens, or whatever filter we can apply. See. So we can apply such filters and we can get responses. We can do user level tracking and filter level tracking, proper analytics. See, traces. So if I go to traces over here, we can see all the trace properly. This is a trace, right? Show all spans. Now we know what this span is, right? One execution of the trace, we can see all of that, right? So yes, this is how, the experiment is. So this is the second experiment, that you don't only, you not only send a request, but you also send information with this request. All right. Let us go to the third one, automatic retries. Okay. So when LLM hit rate limits, occasionally throw 500 errors, which means it is an error number. Without a gateway, your application will crash and user will never see the errors. With Portkey retry config, failed requests are automatically retried in exponential backoff, which means just in case once it was not happened, it will not fail your system. It will retry. Okay. Retrying is also a concept. It will retry, and after retrying, it will do attempts, and after multiple attempts, it will deliver your response. So see, we can see maximum retries, and I can just ask this different question. Tell me a fun fact about dolphins. So this time it worked because there was no retry. Our model is working perfectly fine. Okay. Retry pairs well with fallback. So this is not the best time to see the retry feature. I can show you the retry feature. See how I can show you the retry feature. I can just mess up with my slug. Instead of ABC1, I will do ABC. Now you can see retrying. See. Okay. Error after all retry attempts. Okay. So it is saying that I retried. But we want to see this visually. We will see this visually properly. Okay. So let us see this visually properly. We have something called as timeout. So see people, timeout is another concept. Okay. Run with your timeout. Let me see. So force timeout, we can also force timeout and run with your timeout. So see, what is timeout, people? Timeout means there are many applications which are critical to response. which means I want my response within 10 seconds only. It should not take more than 10 seconds. Okay. So timeout in milliseconds, let me keep it 1000. It is always going to reply in 1000 seconds, So let me try run with your timeout. Okay. It is working. Always it is giving inside 1 second only. But this is simple calls, right? But in scenarios where AI is fetching data from multiple sources, collecting it, giving you the response, I want all that to be done in 10 seconds only. If it is not doing in 10 seconds, go for another model. Leave this model, go for another model directly. Okay. So this is called, you know, timeouts. Okay. If in 10 seconds it is not happening, go for another model. No problem. Okay. So timeout. Next we have is fallback. Fallback routing. What is fallback? You are playing football. Okay. Lot of your opponents have come in your court. You will call your team fallback. Come to me. Save me. Similarly, fallback is the feature when one model is not working, it will go back to the next model. Fall back to another model. So your app request Portkey Gateway, tries with primary model. If this is failing, it will automatically fall back to small model. Okay. Now, usually retry, timeout and fallback, they work together. Okay. I might have taught these concepts separately because they are separate concepts, but they work together. Okay. Now, retry concept will also come in Spotify if when there was no AI. You are searching, you are not getting any results, right? So request timeouts will also come there, that you are searching something, you are not getting it within the time frame, right? So timeouts will be there. Okay, mission critical systems, right? Fallback. So this will be there. Okay, so what I said, retry, timeout and fallback are always used together. Let us see how. Okay. So because what was it? For all the three of them, retry, when will you retry? When one model is not working or model is not replying or it is taking time to reply. Then will you retry? Similarly, timeout. If model is taking a lot of time, go for another model. Fallback. If model is not working, go for another model. So all of them are kind of similar and they are used in a combination, not standalone. Okay, they can be used standalone, but they are usually used in combination. See, first, in 5 seconds it is not replying, retry. Okay, too slow to error, retry. Okay, then now we tried model is not working, again retry. Okay, third, it worked. So let us see that. Okay, now what I will do, timeout per seconds. Okay, retries per fallback. Let us see this scenario. Watch it fall back. This time it worked because everything is fine. Let me show you the fallback part. I will fail my model. I will fail my model by giving it a wrong slug. This means my model will not work. Now when I do it, see, it will fall back. So watch it fall back. Where is it? Request calling primary model, timed out. See, what did we see? Request calling primary model, timed out. Retry 1, calling primary model, timeout. Retry 2, calling primary model, timeout. Activating fallback, switching to different model. Fallback strategy. Okay, one model is not working, go for another model. So till now we never used this model. Okay, do we have it? Let us check. We have this model just now, right? We have this model, right? And we fall back to this model. Let us see error rate if there is. Okay, we should also probably see error rate. Okay, we did not see any error because, error never happened. So this is what I'm talking about, right? Fault tolerant systems. Fault tolerant means the model was wrong. I failed my model. But even though we have a backup in the backend, the system will never fail. We will make our system fault tolerant. Okay. So this is how retry, timeout, and fallback work together. Right? So now that we understand about retry, timeout, and fallback, let us go and talk about load balancing. Okay, which means if we have 100 requests, okay, if we send all these 100 requests to one particular model, this model will take time to reply. So what we want to do, we want to balance the load. Okay, so see this scenario. If 10 requests are coming, it will be passed through your Portkey gateway. 70% of the request will go somewhere else, 30% will go somewhere else. It will be, divided within models, big model and small model, and then it will give the response. So let us see that. We can divide this. We can, make it 10, 20, 80, 40, 40, 60, 50, 50. We can do whatever. Okay. Let us try with 60, 40. Large model will take 60% of the requests. Small model will take 40% of the request. Okay. Now, I have these 10 questions ready. See, 10 questions are ready. What is love, scientifically speaking? How do airplanes actually stay in the air? You know. So all these 10 requests. So we can select these 10 requests. Okay. We can select all these 10 requests. Total requests to fire. Let us fire all the requests and let us see what is going to happen on the backend. I'm just quickly going here. Okay, that was too fast. Okay, the model worked too fast. Okay, but let us see what happened. We have 20 requests directly after 10. And see, 14 requests were received by this and 3 requests were received by this. So I will use other models so that you will understand properly. See, I will use API key. Sorry, I will choose my different model. I will choose a Llama 70 billion model over here. And the other model I can use is, Llama 3.18 billion. So new model is coming into the picture, right? Yes, that model is not there. Now bigger model is Llama and smaller model is that. So if I fire all these questions now, okay. So here we can see the analytics. 5 questions were sent to large model, 5 questions were sent to large model, 0 errors. Okay. And now we see, new requests are received. Llama 30 billion, 70 billion model received 5, and this earlier received 5, now it received more 5. Okay. We're able to trace all of this on a user level, right? And this is amazing. See, our analytics are also increasing. Now, if I show you one more thing, let us try to fail this. Okay. Let us try to fail this main model. Okay. And let me fire all the requests now and let us see how that happens. Now, if I fire 10 requests, all of them failed. Okay. Do we have any error rates over here? All right, let me see. Okay, no error rates. We are not tracing errors, but we do trace errors as well. So cool. No worries. We should always try to fail our systems like that. Okay. And this is done. So this was load balancing the load of many requests. If lot of requests are coming, how do you handle that? Right. Now let us go for a very, very important, very, very interesting topic, caching. It is a very old concept. Okay. You always use it everywhere in each software. It will always be there. Caching. Okay. CACHING. Caching. What is this caching means? Okay. And what is this cache? In caching, we store cache. Cache is, if you have ever used your Android phones or any particular phones, when you go to uninstall our application, you have a button to clear cache. Okay. What is this cache? Okay. What is this cache? This cache is, the memory of your data. What is this memory of your data? For example, you are using a web browser. Okay. You are using a web browser and you are trying to fill a Google form. Okay. Google form. Lot of time what happens is, while filling the Google form, you close it. Accidentally or purposely, you close it halfway. Okay. But when you again open this Google form, it is almost filled. I mean, all the fields which you had filled earlier, they are still there. Okay, they are not gone. This is caching. Okay. The browser which you were using was maintaining your cache. Okay, this is what caching is. I will speak more in more simpler words. Now you are talking with a chatbot. Okay. You are talking to a HR policy chatbot, and to this HR, there is 100 employees in the organization. 1, 2, 3, 4. Out of this 100 employees, okay, let us say the first person is asking, tell me about vacation. Okay, tell me about leave, right? Tell me about promotion, right? And let us say this person is again asking about vacation, right? So now what happened is question is repeated this time. Earlier, earlier when the bot received this kind of question for the first time, vacation question, then it makes sense to search the database and respond from the database. But second time, okay, second time when it is again asked about vacation, this time reply from your memory. Don't go to database. Why? Because you remember the response. And this is how humans work as well, right? If I give you a homework, if I give you an assignment to go and research about LLM gateways, okay, and once you are back, or if I ask you a question, okay, if you are the chatbot, okay, and I ask you what are gateways, if I ask you this particular question, you will go to the internet, read about it, and give me the information. Just how an AI agent will do. Go to the web and give me the information. But when I ask you for the second time, or when your friend is asking you for the second time, hey, do you know about gateways? Without even searching on Google, you will directly give him the response. Okay. As similar as, see, today I am the teacher to teach you gateways. Before the class, I was studying gateways. But when I will take another class on gateways for some another students, I will not study it. I will directly go and teach them, right? This is what cache is. Okay. Once we do it, we remember. So similarly, if people have already asked about vacation and the chatbot remembers that this was the answer I gave for vacation, it will directly pick the answer from the cache memory and it will not hit the LLM again. Okay, this is what caching is, right? Now there are two types of cache. One is simple cache, okay, and one is semantic cache. Semantic, the word semantic means meaningful. Okay, meaningful. So simple cache will check for exact similar words. If I asked what is AI for the first time, it will search the database and give me the response. But if I exactly ask the same question, what is AI again, it will not hit the database, it will not hit anything, it will respond from the cache memory. Okay, so directly it will give me the response. Now, until we did not have those attention mechanisms or until we did not have the transformers into the picture, we were using simple cache. Okay, and there were no smart chatbots as well at that particular point of time. Okay, there were smart chatbots, but they were, neural network driven chatbots. These chatbots are also neural network driven, but these are transformers based chatbots. Let us not go there. These are smarter versions. These are LLMs. Okay. Earlier we literally had deep learning chatbots. Now we have large language models. We can take it like that. Now here the diversity of AI increased, right? Earlier we used to ask simple deterministic questions where exactly checking for this used to work fine. But later, having this chatbot experience, one person can also ask what is AI. One person can also ask, tell me about AI, explain me AI, okay? And all of these questions have a same answer, which is what is AI? Explain me AI. Tell me about AI. All of these have same answers. So this time, even if the question is semantically similar, it will give the response from the database that, okay, only the words are different, the meaning is the same. I will ask from my database. Okay, so let us see this in action. Now what I will do, I will go here and write a question. The question is, I will give a different question. How does internet actually work? This is the question I will give. And when I'm giving this for the first time, see how much time it will take. See, first time I'm running it, it took 1538 milliseconds to give me this response. Okay, and look at the response. Imagine internet the internet you, how it works, back to your whatever. Okay. Now, see this. If I run this for the second time, same question, I'm running the same question second time. Check this out. It took 101 milliseconds. Okay. How fast it responded. Okay. This is the beauty. Okay. And you can see the same response. Imagine internet you, here how it works, and back to your. All right. So this is cache hit. Okay. Cache, using this cache concept, we save our tokens. So if you are asked in an interview that how will you optimize your cost in a large language model, you will say, I will implement caching in my large language model systems to optimize my cost. Let us see how this cost looks like. So I can simply go to cache and we can see we have a new spike in cache. See, we have a new spike in cache. We hit this cache for the first time. Okay, if I go to logs and if I show you this latest query, here what we can see is 0.02 cents were saved because cache was hit. Okay, cache was hit. That is how we saved our tokens. We responded from our memory. Okay, and this is telling that cache is refreshed for this particular question. Let us see this cache one more time. I will ask, why is the world so mean? Okay, I'm just simply asking it. Let us see AI's response. Okay, and if I run this question, what a profound and relatable question. It took this much time. And if I check the logs, this time cache was not hit. Cache was refreshed for this particular question. Okay, run this same question. It responded me in 912 milliseconds. Okay, cost is saved, time is saved. If we check over here, again tokens were saved and this time cache was hit for this particular question. Okay, so for similar questions it will reply. All right, and this was caching. Lastly, we have rate limiting. So rate limiting means, rate limiting means you are using OpenAI. You have a large language model ready, but when you are giving it to users, you want to apply subscription plans. You only want to give your users that only use 10 requests. Don't use more requests. Okay. If 10 chats exceed, a pop-up will come, subscribe to our, framework, subscribe to our, the technology for having more benefits, right? We have all seen that. Subscribe to our pro plan. So that is how you do rate limiting as well. You can see, you can hit retire limits, rapid fire requests, okay? And you can do the rate limiting concept, okay? Then we have streaming. Streaming is very simple, okay? See, streaming, I will show you again ChatGPT. What is AI? See the response, okay? It will stream the response word by word. See, it will, okay, it was so fast. Why was it fast? Someone might have asked it. Who knows, right? So see, here also I think, okay, try again faster answers. Okay, so we can see, we can say, search the web and tell me about Portkey. It will stream the response. Check that out. Okay. See, it is streaming in front of us. Okay, I don't know why I'm facing this lag, but see here also it is streaming in front of us, one after the other. It is streaming one word after the other. So this is what streaming means. We can do this streaming as well. Check this out. Okay, I'm asking this question, what is AI? Okay, we want to see 250 tokens in the stream. So first we will see get response full at once. We can do both of them then. So get response full at once. It will take a second and it will give us full response. But here I will write what is life without AI. Okay, it will stream. See, it will stream. You saw it streaming. This is streaming. Okay, we can stream lesser words as well. We can stream 100 tokens as well. Okay, so see, we saw it streaming, right? And this is what streaming is. So yes, These were all the different experiments of Portkey. Okay, not really Portkey. These were all the experiments for LLM Gateway. Okay, this link is provided. You can add your API keys and you can experiment all the different experiments to get your hands on and understand the concept. Okay, and see, cache was hit. We can trace everything, right? And yes, I hope you enjoyed it and I hope you loved it. And that brings us to the end of this particular concept. I really hope you love the explanation and I really hope you have tried the demonstration. So see you in the upcoming videos with such more interesting and interactive concepts. Until then, see you, take care, bye bye, and have a good life.